Ever wonder how your phone's processor or your laptop's graphics chip gets built? It's not just code. It's a mind-bending puzzle of circuits, logic gates, and precise instructions. And here's the wild part. Researchers are now using AI to write the code that designs these chips. But here's the catch. Current tools for testing this AI. They're like trying to learn calculus from a children's book. Let's break it down. Hardware design automation is the process of creating chips using software tools. But when AI starts writing the code for these tools, things get tricky. Think of it like teaching a robot to bake a souffle. Sure, it can follow a recipe, but if the instructions are vague or missing key steps, the result? A collapsed dessert. That's where RealBench comes in. It's a new benchmark, basically a supercharged test, to see how well AI can generate Verilog code, the language that tells hardware what to do. But here's the twist. RealBench doesn't use simple toy examples. It uses real-world designs, like encryption cores, SD card controllers, and even a full CPU called Hummingbird 2. These aren't basic projects. They're complex systems with thousands of lines of code, nested modules, and detailed specifications. Imagine trying to build a skyscraper using blueprints that only show a single room. That's what current benchmarks are like. They lack the complexity of real hardware, missing things like dynamic constraints, hierarchical structures, and proper verification. RealBench fixes this by including 100% line coverage test benches, like a detective checking every sentence of a novel, and formal verification tools that mathematically prove the code works. So how did AI perform? Researchers tested top models like O1 Preview, and the results were sobering. On module-level tasks, like designing a single circuit, the best model only succeeded 13.3% of the time. And on system-level tasks, the whole chip. 0. Why? Because real-world hardware isn't just about writing code. It's about understanding interdependencies, constraints, and verification. The problem isn't the AI itself. It's the tools we're using to test it. Traditional benchmarks are too simplistic, like teaching a kid to ride a bike with training wheels that don't actually support them. RealBench is the upgrade, rigorous, realistic, and designed to push AI to its limits. The takeaway: AI is still in the early stages of mastering hardware design. But this isn't a dead end, it's a roadmap. Just like software engineering saw rapid AI progress, hardware design is about to catch up. And tools like RealBench are the training wheels that'll get us there. So the next time you hear about AI writing code, remember, it's not just about typing fast. It's about tackling the complexity of real-world systems. And with benchmarks like RealBench, we're one step closer to AI that can design the future, chip by chip. Thanks for watching. If you want to dive deeper into how AI is reshaping hardware, hit subscribe. See you next time. But here's the thing. AI isn't just rewriting code, it's redefining what's possible. Take DeepSeek-Coder, for example. This model doesn't just guess at solutions, it understands the logic behind code. Trained on vast datasets, it identifies patterns and structures, writing cleaner, more efficient code, and even debugging complex issues like a seasoned developer. Then there's VerilogCoder, which uses graph-based planning to map out code architecture before writing a single line. It's like sketching a blueprint for a house before breaking ground. Its use of abstract syntax trees, ASTs, lets it track how code behaves over time, catching errors before they become disasters. And let's not forget Code QN from Alibaba. This tool learns your coding style, offering suggestions that feel almost human. It's like having a teammate who's been working alongside you for years, anticipating your needs and refining your work. For versatility, Llama 2 is a powerhouse. Its open-source nature makes it a Swiss Army knife for developers, handling everything from code generation to general tasks. Whether you're a hobbyist or a pro, it's a flexible ally in your toolkit. Finally, Origen takes code generation to the next level. By using code-to-code augmentation, it improves existing code by learning from similar examples. Its self-reflection feature acts as a code proofreader, catching mistakes before they cause chaos. These tools aren't just about speed, they're about making code smarter, more reliable, and easier to work with. As AI gets better at programming, the line between human and machine is blurring, and the future of coding is looking pretty exciting. What do you think? Are you pumped about AI helping us code better, or do you prefer writing it all yourself? Drop your thoughts below, let's chat.